Have you ever been reading something about quantum mechanics and a single sentence just stops you cold? Suddenly, you're not reading science anymore. It sounds way more like something you'd find in an ancient Hindu text, or maybe hear a Zen teacher say. Well, today's explainer is about a man who lived exactly at that intersection. We're looking at David Bohm. He was a brilliant quantum physicist who actually studied under Robert Oppenheimer and debated Albert Einstein. But, as we're going to see, Bohm's radical scientific theories ultimately uncovered the exact same architecture of reality as ancient Eastern wisdom.
Just listen to this thought for a second. At the deepest level of reality, separation is an illusion. Everything is enfolded into everything. I mean, it immediately brings to mind some contemplative sage, right? Whispering secrets about the universe that have been passed down for millennia. It perfectly captures that wordless, intuitive feeling that the world isn't actually made up of separate, disconnected things.
So what do you think? Did a mystic say this or a quantum physicist? Turns out it was actually David Bohm. This incredibly profound realization came from a rigorous scientist who spent his entire life trying to understand the hard mathematical fabric of the universe. But as we'll uncover today, his journey to get to this realization was, well, anything but conventional. In fact, before he even turned 40, he was exiled from American science and forced to spend the rest of his life living in other people's countries. Section 1. The Physicist in Exile. How losing institutional safety sparked a scientific revolution. To truly understand Bohm's revolutionary ideas, we really have to look at where they came from. They weren't born in the comfort of some prestigious university lab. They were actually born out of political exile. So back in the late 1940s, the House Un-American Activities Committee, HUAC, was investigating communist influence in American institutions. In 1949, they summoned Bohm. At the time, he was a brilliant, politically quiet assistant professor at Princeton, but he did have ties to left-wing groups as a student. The committee demanded that he testify against his colleagues. Bohm invoked the Fifth Amendment and refused, which led to his arrest for contempt of Congress in 1950. Now, he was actually acquitted in 1951, but Princeton still suspended him and declined to renew his contract. Shortly after he took a position in Brazil, the U.S. consulate confiscated his passport. He was completely stripped of his institutional safety and effectively forced out of American academia. But ironically, operating entirely outside the reach of scientific orthodoxy is exactly what freed his mind to look at physics completely differently. While Bohm was still at Princeton, he actually wrote a textbook on the standard Copenhagen interpretation of quantum mechanics. Albert Einstein, who was a close intellectual peer of his, basically told Bohm it was the clearest account he'd ever read, and then casually added that he didn't believe a single word of it. Einstein really nudged Bohm, insisting there had to be something deeper, something real underneath the mathematics. And so, during his exile, Bohm set out to find exactly that. Section 2. The ink drop metaphor. Visualizing the hidden architecture of the universe. Okay, let's dive into this, because Bohm came up with a genuinely brilliant visual demonstration that changes literally everything about how we understand reality. Imagine two clear cylinders, one nested inside the other, and the gap between them is filled with a really thick, syrupy fluid. Now you drop a single bead of ink into that fluid. Then you slowly turn a crank to rotate the inner cylinder. As it turns, the ink stretches out into a long thread, thinning out more and more until it completely disappears. The fluid just looks perfectly clear again, but here is the magic. If you crank it the exact same number of turns backward, the thread reappears, it thickens, and the drop perfectly reassembles exactly as it was. The physical order of that ink drop was never actually destroyed, right? It was just hidden. And this brings us to a really crucial concept: enfolded. The order of the ink wasn't gone, it was enfolded into the fluid. Bohm believed this is exactly what reality is at its core. It's this underlying domain where things don't just vanish, they simply fold into the deeper fabric of the universe. Which leads perfectly into Bohm's concept of the explicate order. Think of this as the unfolded surface of reality. It's what you and I experience every single day. The objects we pick up, the particles physicists measure, all the separate things we see existing around us in space and time. It's the ink drop when it's fully visible and assembled. But the key takeaway here is that it's only the surface. Because right underneath that surface lies the implicate order, and it is a fascinating contrast to our everyday experience. This is a deeper, totally undivided wholeness where everything is folded into everything else. It is non-local. Just like that invisible ink thread stretched all throughout the clear syrup, the universe at this deeper level has no separate parts. Absolutely everything connects. And the thing is, reality isn't some static, frozen picture. Bohm called the relationship between these two states the Holomovement. It's a constant, dynamic unfolding and re-unfolding process.
An electron, for example, isn't just a tiny hard ball bouncing around in space. It's more like a continuous pattern of appearing and disappearing within this flowing totality. The holomovement is a living, breathing process that you just can't fully capture with fixed mathematical descriptions alone. Section 3. A non-local universe. Giving philosophy mathematical teeth. Now, you might be thinking this all sounds like beautiful poetry, but Bohm actually gave it serious mathematical teeth. Standard quantum theory, which pretty much most physicists just accepted as gospel, says particles don't even have definite positions until you measure them. But in Bohm's completely reworked pilot wave theory, particles always have definite positions, and they're guided by a real underlying wave field. He essentially solved the paradox of how things operate at the quantum level by introducing a totally new framework. He called this framework the quantum potential. It's a field that doesn't push particles around with physical force like a wave in the ocean, but rather it informs them. It literally puts form into them. It carries information about the entire system, non-locally and instantaneously. This means that two entangled particles sitting all the way across the galaxy from each other behave as one, not because they're sending some spooky, invisible signals back and forth, but because they were never actually separate to begin with. They are both just unfoldings of the exact same implicate order.
And if you want to know just how well Bohm's incredible intuition held up over time, look at this number, 2022. That is the year the Nobel Prize in Physics was awarded to scientists who finally proved, through rigorous entanglement experiments, that the universe is indeed non-local, building directly on John Bell's theorem from 1964. And Bell himself said his work was directly inspired by reading Bohm, by the way. Modern physics confirmed what Bohm knew decades earlier. The universe is deeply, fundamentally non-local.
Section 4. Mind and matter entangled. Where does consciousness fit into the implicate order?
Where most physicists were perfectly happy to stop at the equations, Bohm kept pushing the boundaries. He asked a truly radical question. Where exactly does human consciousness fit into this whole picture? He once stated, "Even the electron is informed with a certain level of mind." Bohm coined this term soma-significance. Basically, he argued that mind and matter are not two separate, distinct substances at all. Instead, they are just two aspects of one single underlying movement, meaning shapes matter, and matter gives rise to meaning. If the quantum potential guides particles with information, then meaning is woven into the very fabric of reality itself. Consciousness isn't just some accidental byproduct of the brain, it is something the implicate order inherently is.
Section 5. Physics meets ancient mysticism, arriving at the same architecture through different languages. You can probably see how Bohm's line of thinking naturally led him way outside traditional scientific circles. He actually spent 25 years in deep dialogue with the philosopher sage Jiddu Krishnamurti, exploring the unmanifest source of thought and time. His blending of science and wisdom was so profound that the Dalai Lama actually called Bohm his science guru. And honestly, it's easy to see why. Look at this. Bohm's scientific architecture perfectly mirrors ancient traditions. He's just using a different language. Bohm's implicate order is exactly what Vedanta calls Brahman, the infinite ground of pure awareness. His explicate order, that surface level we mistake for the deep reality, is what Vedanta calls Maya. Bohm's flowing holomovement, which he said is undefinable and immeasurable, that maps flawlessly to the Tao in Taoism, which famously states the Tao that can be told is not the eternal Tao. And his concept of enfolded reality, where every part contains the whole, that is literally Buddhism's Indra's net, an infinite cosmic net where every single jewel reflects every other jewel. I mean, it is a massive aha moment. They are describing the exact same underlying architecture. Section 6. The illusion of separation. Finding wholeness in a fragmented world. So what does this all mean for us? Why does this matter to you and me today? Well, we live in a world of extraordinary fragmentation, don't we? Political, psychological, spiritual fragmentation. We are constantly trained by our culture and our language to see the world entirely through duality. Me over here, you over there, mind completely separate from matter. But Bohm spent his entire life proving mathematically that this fragmentation is just an illusion of our thinking. It is not a feature of actual reality. True wholeness is the deepest, most fundamental feature of our universe. As Bohm powerfully concluded, deep down the consciousness of mankind is one. If we don't see this, it's because we are blinding ourselves to it. The implicate order simply doesn't care about our human categories. It holds everything, both matter and mind, in one unbroken, magnificent movement. David Bohm survived political exile and professional isolation to uncover a mathematically rigorous framework that essentially proves what ancient sages have been whispering for thousands of years. The universe is an undivided whole. The physicist saw exactly what the mystic saw. So the only question remaining for us on this final slide today is, are we ready to see it too? Thanks so much for joining me on this explainer. Keep questioning, keep learning, and I'll catch you on the next one.